Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer financial support in the form of a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam IFM, Investments and Financial Markets. Near market closing time on a given day, you lose access to stock prices, but some European call and put prices for a stock are available. All 6 options have the same expiration date, and you're given strike price 40, 50, 55, and call price of 11, 6, and 3, and put price of 3, 8, and 11. After reviewing information above, John tells Mary and Peter that no arbitrage opportunities can arise from these prices. Mary disagrees with John. She argues that one could use the following portfolio to obtain arbitrage profit. Long 1 call option with strike price 40, short 3 call options with strike price 50, lend $1, and long some calls with strike price 55. Peter also disagrees with John. He claims that the following portfolio, which is different from Mary's, can produce arbitrage profit. Long 2 calls and short 2 puts with strike price 55, long 1 call and short 1 put with strike price 40, lend $2, and short some calls and long the same number of puts with strike price 50. Which of the following statements is true? A. Only John is correct. B. Only Mary is correct. C. Only Peter is correct. D. Both Mary and Peter are correct. And E. None of them is correct. And here's the solution. Note that the prices are not arbitrage-free because of convexity violation for calls. Specifically, let's take lambda to be K3 minus K2 over K3 minus K1. That's 55 minus 50 over 55 minus 40. It's 1/3. So the distance from 50 to 55 is 1/3 of the way from 40 to 55. And K2, which is 50, is 1/3 times 40 plus 2/3 times 55. To satisfy convexity, we should have that the call price or the exercise price of K2 should be less than or equal to 1/3 of the call price with exercise price K1 plus 2/3 of the call with exercise price K3. However, we actually know that C of K2, which is the price at the exercise price of 50, K2 is 50, that's 6, and that's more than 1/3 times 11, C of K1, and K1 is 40, plus 2/3 times 3, which is C of K3, and K3 is 55, and that's equal to 17 over 3. And of course, 6 is 18 over 3, so 6 is more than this. Note that convexity is not violated for puts. Below is an analysis showing that Mary's portfolio yields arbitrage profit if she decides to buy 2 calls with strike price of 55. The number of calls with strike price 55 is implied by the convexity violation in the price of calls. If you have this condition violated, that says that the left-hand side is too expensive, the right-hand side is too cheap, so you would always buy the cheap and short the expensive one. So here is a table that shows you what happens if you buy 1 call at strike price of 40, sell 3 calls strike price of 50, which will give us 18 in proceeds. You buy 1 call at strike price 40 that costs 11, and you lend $1 and you buy 2 call strike price 55, and this lending of $1 for the purpose of producing a total of 0 investment at time 0. Then, at time t, at expiration, if the price of a stock is less than 40, the payoff of the first two positions is 0, then the accumulated value of $1 is e to the RT, and 2 calls for strike price of 55, 0 payoff, and the outcome is that the position is worth e to the RT, which is positive. At time t, if S sub t is between 40 and 50, then by 1 call, a strike 40, the payoff is S sub t minus 40. Sell 3 calls, strike 50, the payoff is 0. Lending of $1, the payoff is e to the RT. Buy 2 calls, strike 55, the payoff is 0. And the net payoff is e to the RT plus S sub t minus 40. That's positive because S sub t is more than 40, greater or equal to 40. Then when S sub t is between 50 and 55, the first position has a payoff of ST minus 40. That's the way it's going to stay as long as the stock is above 40. The short 3 calls strike 50 position is worth minus 3 times S sub t minus 50. Lending of $1 is e to the RT. The net position is e to the RT and plus 255 minus ST. And that's positive. And the reason why this is positive is because, of course, S sub t is less than 55. How do you get to this 255 minus ST? Well, you need to add the two positions, ST minus 40 and minus 3 ST minus 50. Negative 3 times negative 50 is going to be 150 minus 40, that's 110, and 110 is equal to 2 times 55. And then ST minus 3 ST is minus 2 ST. So that's how you get this value, the payoff. If S sub t is greater than or equal to 55, by 1 call strike 40, payoff is S sub t minus 40. Sell 3 calls is minus 3 times S sub t minus 50. Lend $1, the payoff is e to the RT. Buy 2 calls, strike 55. The payoff is 2 times S sub t minus 55. And if you net all of those, all you get is e to the RT, which is positive. Therefore, there's a positive payoff. So you can see that in every possible state of the world, there's a positive payoff. 0 net amount of money spent on the position. This is an arbitrage. Before talking about Peter, let's look at his portfolio. In addition to lending $2, he has long 2 calls and short 2 puts with strike price 55, and long 1 call and short 1 put with strike price 40, and short some calls and longs the same number of puts with strike price 50. And note that long call plus short put is long forward, and short call plus long put is short forward. So, for example, the payoff at time t for long 1 call and short 1 put with strike price 40 is S sub t minus 40 for any value of S sub t, since we have to get the stock back for $40. We get the stock for $40. So Peter is long 2 forwards with exercise price of 55 and long 1 forward with exercise price of 40. He's also going to be short several forwards with exercise price of 50. Well, it turns out that, of course, specifically, Peter's portfolio also generates arbitrage profit if we assume he buys 3 puts and sells 3 calls for strike price of 50, so he shorts 3 forwards with exercise price of 55. And here's what happens. So buy 1 call, sell 1 put, strike price 40, sell 3 calls and buy 3 puts, strike price 50, lend $2, buy 2 calls and sell 2 puts, strike price 55. That's a net 0 position, and the cost at time 0, well, there's a net payment to him of 8 for the first position, 6 for the second position, but he spent 16 for the third position. So with the lending of 2, the net cash flow is 0 times 0. And at time t, the total payoff that he has is s sub t minus 40 plus 3 times 50 minus s sub t plus 2e to the rt plus 2 s sub t minus 55. You net all this and the payoff is 2e to the rt. So 0 initial investment and a payoff of 2e to the rt at time t. That's an arbitrage. So this is answer D. Please remember, this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies and good luck on the test.